Alrighty, guys. So we're gonna move on to the next thing here. This is the last unit. We're gonna be looking at exponential graphs and logarithmic graphs over the next 2 weeks, and then we will be doing at least one more assessment before the end. And believe it or not, we're that close. So without, I guess, further ado, what we're going to do today is look just at the graphs, okay, and how to translate the graphs, all right? So when you're focusing today, you are not focusing on actually how to graph. You're going to be focusing on what the graphs actually look like, because when we do the assessments for this, you're not actually physically going to have to graph it. What you're going to have to do is describe what's going on in the graph and be able to recognize what the graph actually looks like. So just be ready for that. That's what we're going to be paying attention to. You're not really worried about exactly how to graph it. Once again, you are more worried about how it looks. Okay, so the first piece here, we've got some definitions for you and some formulas. So as you can see here, an exponential function, what it looks like is y equals ab to the x. Okay, what's going to make it exponential is that b to the x. Okay, that's where our exponential is coming from. A is just a constant, b is a constant as well, and again the x is where you're going to see your exponent, which is your exponential piece of this. Okay, the two things that you got to remember: exponential growth. Okay, growth comes from when your b is bigger than 1. Okay, so the number that is attached to the exponent is bigger than 1. And decay, when the b is less than 1. Okay, so you'll see examples of each. Okay, and the last little definition here is an asymptote. Okay, an asymptote is a line that the graph approaches but never actually crosses. Okay, so you can't touch the asymptote, basically, is what you need to remember here. Alright, so first thing, let's take a look at just a graph that's already done for us here. Okay, so here I see an exponential growth graph. This is the parent function. Okay, in other words, this means both a and b are 1. Okay, so this is what it would look like. Okay, as you can see from left to right, the graph starts low and then all of a sudden shoots way up really fast. Okay, so the green line that you see on your screen here is the asymptote. Okay, I know it on the left hand side. They look like they overlap, but they actually don't. It's just because the marker was a little too thick when it was originally drawn. Okay, it actually never touches that green line. All right, looking at decay, same scenario here. Okay, except now this time your b is less than 1. Okay, so what's going to happen is, as you see, it starts high and drops low. Okay, and again, in this case, it does not touch the green line, and that green line would be known as your asymptote. All right, so first thing we're going to do is we're going to figure out if we've got growth or if we got decay. Now remember, what we're looking at is, what is b? Is b greater than 1 or is b less than 1? Okay, so those are the two things we're looking for here. Okay, greater than 1 we got a growth, less than 1 we got decay. I don't know why my pen is not working here. Decay. Okay, so if I'm looking at this, I see, remember, this is A, this is B. Okay, so my B here is 2. B being 2 tells me, hey, this should be a growth. Okay, 2 is bigger than 1. So we would use that as a growth. All right. Over here, with this next one, again, in this case, A is 1, B is 5, so I believe 5 is bigger than 1, so I'm going to call this a growth as well. Okay. So there you go. All right, go ahead and come down here. I've got 3 times 1/2. Again, the 3 is A. The 1/2 is B. Last time I checked, 1/2 is less than 1. So this would be an example of decay. Okay, and then finally, the last one over here. Okay, I have 0.2, and once again, 0.2 is less than 1. So because of that, I would say we have decay. Okay, so Should be pretty quick for you guys to identify what it's going to be just by looking at the numbers, okay? So that should be something that you should not really have too much of a problem with. You're looking just at the B value, all right? So now let's graph one really quick here. Okay, we're going to figure out if it's growth or decay. Right away, I should be able to tell what it is based on the fact that I see a 2 here, right? So in this case, B is 2, so that would tell me I have a growth. Okay, so now what I'm going to do is I'm going to go ahead and start looking at how to actually graph this, all right? And how we actually graph this is we go ahead and we make a little chart here, or a little T-chart. Every time we graph, we do this, okay? So normally what you're going to want to do, you know, you're going to kind of want to see where everything is going on at. In this case, your X, okay, you can kind of pick your values, all right? So what you're going to do here is you got a 0. Generally what I would do is I would pick above and below just to kind of get a better representation of what's going on. So I'm going to do 1 below, I'm going to do 2 above here, since I'm kind of out of room, I'm just going to kind of do it this way. So what I'm going to do is start with -1. Okay, if I start with -1, so when x is -1, all I'm doing is going back to my original, this 2 to the x, and I'm plugging in those x's, right? So 2 to the -1. Well, 2 to the -1, if we remember our rules, just says, hey, flip everything. So this is really just 1/2. So that would make my y 1/2 or 0.5. Okay, when I put in 0, anything to the 0 power is 1. Okay, 1, if you put in 1, you get 2, 2, you get 4, right? So now if I'm graphing this, all right, at 0, I have 1, okay, at -1, I have 1/2, okay, sorry guys, this stylus is not very good, okay, at 1, I have 2, okay, and then at 2, I have 4, all right, and basically what you're going to see is the asymptote here is y equals 0, just so you know. So basically what I'm going to do is I'm going to draw this, okay. Notice that it never crosses the 0, okay, it never crosses y equals 0, which is that horizontal line there, okay. So the asymptotes that we're going to be looking at right now are going to be horizontal. All right, so there's your first graph. Okay, so notice again, it starts low, shoots up high. Okay, so again, you're going to be given a graph like that, and you're just going to have to tell me, hey, is it growth or is it decay? All right, over here, all right, let's take a look at this one. Again, right away, I should be able to tell what's going on because I have a 0.2 there. That 0.2 is going to tell me to, hey, this is decay. All right, so because of this, I'm going to go ahead and circle decay or box it. Okay, what I'm also going to do is I'm going to start making my numbers here. And again, I'm just going to pick the same ones I picked last time for sake of argument. Let's see here, -1, 0, -1, or I'm sorry, +1, and 2. Okay, so again, basically what's going to happen now is you're going to go ahead and you're going to plug it in. All right, and then so what we're going to do now is just start plugging stuff in, right? So I'm going to go ahead and do that. So if I plug in -1, and I just went to my calculator to get these values, so you plug it in your calculator, you're going to get 25. Okay, when I plug in 0, I get 5. Alright, when I plug in 1, I get 1. Okay, when I plug in 2, I get 0.2. Okay, so notice -1 gives me 25. That's not going to help me. I'm not going to graph that. So I'm actually going to start with the 0. So 1, 2, 3, 4, 5. Come on now. Okay, 1 and 1. Come on. Alright, this is, again, I apologize, this stylus is not doing me very good today. Alright, so we're going to get close to it. Alright, so there we go, and then 0.2 at 2, which is here, roughly. Okay, and again, I know that at -1 it's way up top, so I'm going to go ahead and slide it down here. And again, just by looking at how this pattern is going, it's going to get close to 0, but not actually touch it. So again, our asymptote here is 0. Okay, so again, just being able to identify that, you know, it starts high, drops low, that is decay, that is what you're looking for here. Alright, so we're going to move past this to the next piece. Okay, the next piece is just a horizontal movement. Okay, so this is our shifts. Okay, so we have vertical shifts, we have horizontal shifts, and we actually now have a formula for the asymptote. The asymptote is equal to whatever that k value is. So the equation, if you will, expands. It's no longer y equals ab, it's now y equals ab to the x minus h plus k. And as always, hopefully you guys remember this from the other stuff, anytime we do h, we're always thinking opposite of h. Okay, so that's what we're going to do here. So first, let's take a look. We're just going to describe the translations. Okay, so describing. All right, so I need to be able to identify what each piece is here. Okay, so if I'm looking at this at first, I see an A, I see B, I see the X, and I see an H. I also, there is no K in this case, so that's okay. Doesn't really help us that much, but whatever. So what we're going to do is we're going to say, okay, well, how does this shift? Okay, the only shift that I can talk about here is a horizontal shift. All right, this horizontal shift, it comes from that plus h. Now remember, we're talking opposite, so if I see +2, you really think right, but because we do opposite here, this is actually a shift of left 2. Okay, same thing over here. If I'm looking at this again, I see an A, a B, an X, and an H. So still no K. So that means, again, I'm only focused on, am I shifting left or right? In this case, I see -5. Now remember, that means I'm going to go ahead and do the opposite. So instead of left 5, I'm going to say right. Come on. I'm going to have to get a new stylus. Right 5. Okay? Alright. I'm going to go ahead and look at the next one. Okay, the next one, alright, is, I see A, B, X, H, and K. So I have an H here, I have a K here, right? So remember, K is the exact same as what you see. That is your up or down shift. And the H is opposite. So if I'm doing opposite of H, I see -3, so that should really be +3. So I'm going to say right. Okay, right 3. Okay, I'm not going to actually write out right anymore. Okay, and then I'm going to say for the K, it's +10, so up 10. Okay, same thing over here. If I'm looking, I see H and I see K again. So how does it shift? Opposite of H, same as K. So opposite of H would be left 7. Yikes. And then down 7. Okay. Here, there's no H, so there's no horizontal shift, but there is a K, so I just have to deal with that, which is up 4. Okay, and then finally, here again I have an H and a K, so H is +1, so really I want to think opposite, so left 1, and K is -5, so that would be down 5. Alright, so there's your shifts. Okay, shouldn't be too bad. I'm running out of time here on these notes, so I don't think I'm going to graph this last one, alright? But basically, you would notice on this graph, you would notice some shifts and things like that. So actually, hold on, let me go ahead and graph this, and I will just show you what it looks like. Okay, guys, clearly I need a better stylus, but that's what the graph looks like, okay? Notice that you should pick that shift that you do to start, so I picked -2 to start, and that's what it looks like. Alright guys, so there you go. Your asymptote is at 3.